Hello Internet, my name is Quentin and this is Blondihacks. I'm working on my locomotive this week. We're continuing with the fire management system. Today we're going to build the ash pan, which sounds simple enough, but there's actually a whole mechanism around it that allows you to clean it, and also the ash pan is responsible for getting airflow up into the coal fire. So there's more going on than you might think. Should be fun. Let's go. The ash from the coal fire falls down through the grate we made last time and needs to land in a pan underneath. And this is a grate so that the ash is kept away from the fire so it doesn't choke it out. And also the fire gets its air up from underneath through this grate. So the ash pan needs to be able to catch the ash, but also be kind of open so air can get up into the fire. And also it needs to hinge downward or have some other method of cleaning the ash out from underneath it. If you know your steam locomotives, one thing you might notice is missing is a damper. The ash pan also serves to direct airflow into the fire, as I said, so most steam locomotives will have a damper control at one end or the other of the ash pan so that you can control how much air is coming into the fire. This locomotive design does not have that. That was a choice Kozo made, I'm sure. You got to keep in mind that this locomotive was designed as a beginner locomotive builder project. So Kozo has simplified as many things as can be reasonably simplified to make it easier to build for your first time. And so one of the things he's left out is any kind of damper control. And there's lots of these that are out there that run just fine. It just isn't necessary in such a simple locomotive. So that's what we're going to build today. I started in my scrap bin, of course, as I always do, but unfortunately I didn't have anything the right size, so I got to go over to the fresh stock and cut a chunk of this out for the rather large folded sheet metal assembly that forms the pan. I always feel like I'm making things for free if I can use only materials out of the scrap bin, so I try to always do that, even though, I did pay for all of it at the end of the day. Now I'm going to make two bends to make this into a U shape, so I've laid out the bends here on the surface plate. I'm going to do one of the bends first and see how that goes. One of the big challenges with sheet metal bending is getting the bends in exactly the right place, especially when you have to hit like a sub 5,000th dimension. I'm going to try to do this on my little bending brake. So I'll put one bend in first. I'm going to get it very carefully aligned on my layout line as accurately as I can. Bend that 90 degrees. And then what I'm going to do is I'm going to take that out and I'm going to measure the outside dimension that I'm trying to hit according to the drawings to where my other layout line is, and that'll tell me how much error there is in this process, like how much of the bend is consuming the material and what the radius is and how that affects the dimension. And then from here I can calculate an error factor, adjust the layout line for the other bend, which I went off camera and did, and now I can come back in and bend the second one on that second line. This was my attempt to compensate for the error inherent in this process. In the second bend I couldn't get all the way to 90 degrees because there wasn't enough clearance on the back of the brake, so I did a little bit of hammer forming on the bench to finish that up. I've left lots of extra material as well on either side of all these bends so that I can move them as needed. Then I'll measure the final result, and survey says it's hot garbage. Yeah, I missed that dimension by about 160 thousandths, and the error I calculated was about 80 thousandths. So I think I adjusted for the bend error in the wrong direction. Yeah, so you know what? Let's just pretend that never happened, and I'm going to do this a different way. I am going to hammer form this, because hammer forming is much more reliable, especially when you have to hit a really accurate dimension, or at least a reasonably accurate dimension as far as sheet metal assemblies go. So I cut a chunk of this old ratty scrap of aluminum on the bandsaw, and I'm going to shape this to the outer dimension of the assembly minus 2 times the thickness of the material. So I'm creating 2 parallel sides, and these will be my hammer form. Granted, aluminum is easy mode when it comes to surface finish, but my goodness, look at that. We've got scale legibility, which I think is the first time I've achieved that on the shaper. Of course, the only real judge of surface finish is Swarfy. He'll do an inspection for me, and if he sees his own reflection, indeed he does. Yeah, look at that. Yeah, Swarfy does not play well with other ducks. No, you're projecting. Shut up. Because this is a hammer form, I need to radius the corners now. I dug through my high-speed steel scraps and I found this grooving tool that some past machinist had ground. And it's a grooving tool, not a radius cutting tool. However, said past machinist desperately needed to dress his grinding wheel, and because he didn't, there's a very nice corner radius on the inside of that grooving tool. So his lack of grinding wheel maintenance is my win. I'm going to use it as a radius cutting tool. There's very nice clearances on the back of it, so it should do the job. I have radius cutting tools for my lathe, but I didn't have one the right size, but this looks about right. I'm feeding down very, very slowly. You can't see my hand, but I'm feeding down on the tool head until it just starts grazing the top surface, and then I'm going to start feeding over into the radius to make the cut. I'm feeding by hand, and I've got the shaper running nice and slow because this is a form tool. So on each idle stroke, I'm feeding over a little bit at a time and just kind of monitoring how it's cutting and seeing that radius develop. I've never used a form tool on the shaper before, so I didn't know how this was going to go. But I gotta say, that is doing a beautiful job. What a nice radius, eh? Look at that. I don't know how big I could get with this before it would start to chatter. It would at some point, but up to here, at least in aluminum, the shaper was extremely happy about doing that. That's a very nice little radius. Well, job done. Now I can flip the part around and I'll cut the same radius on the other side. Of course, the radius tool can only cut in one direction, so flip the part, make the same cut, and Bob's your uncle. I cold formed when I used the brake, but we can't do that here because we're hammer forming, so I'm going to anneal this over on the hearth, get the whole thing nice and hot, reddish orange, and then let it cool down naturally, and then it'll be nice and soft for the hammer form. I've scribed the approximate location that I want the first bend to be. You can't see it on camera because, of course, the torch burns the Sharpie off, but I can see it in person because it is a physical scratch in the material. So I line that up with one edge of my hammer form, and then the other bend will end up wherever the hammer form tells it to end up. I'm using a piece of hardwood as a backer board, and away we go. If you watched the boiler build part of the series, you're very familiar with this process. This is something I did a whole lot in that part of the playlist. And that worked great. I got a really nice fit on that hammer form. Nice thing about hammer forming, it's a little bit more setup work than other sheet metal methods, but it's extremely reliable. And it always gives good results. So dimensionally, I'm about 10 thou over, which is probably thickening of the material due to the shrinking that occurs in the bends. Because if you look at my hammer form, it's dead nuts on size minus 2 times the material thickness. So that little bit of bulging in the corners is what we're seeing, and that won't hurt anything though, because what I care about is the fit at the top edges around the hinge points on the grate rails, and those fit very well. So job done. Hammer forming was the way to go. I was probably going to have to make that hammer form anyway, because as you'll see, I'm going to need it in a bunch of subsequent operations. Over to the surface plate now to lay out the shape of the ash pan. I looked at both ends to see which one was the most square. I've left this over length because I was fully expecting to have to file or mill one end of it square so I could do some layout and have a reference. But honestly, both ends came out nice and square. So I picked one, decided that was my finished end, and I'll lay out from there the overall shape of the ash pan. As you can see in the corner, it's got kind of a funky shape. It's got a lower section and then a taller section at one end where it hinges, and then there's a bunch of angles on it that are clearances for the hinging action that it needs to have. I've also marked what the finished length of it will be on what is now the quote-unquote rough cut end of it. I've also laid out the pivot points, which will be the reference for the angles. So I'll do a little center punch there, which will allow me to scribe a tangent arc around the pivot point, because this tangent arc is what needs to be used as a reference to lay out the 45-degree and 25-degree angles that form the clearances around the top of this for the hinging part of it. to rough cut that in because there's a lot of material to remove and there isn't clearance to get in there with a fret saw. I decided to try using the hammer form as kind of a backer block to support the material under the bandsaw, and I gotta say, that worked better than it had any right to. That was a little sketchy, and that probably shouldn't be something I got away with, but I did. It worked incredibly well. That was sufficiently sketchy that I didn't trust myself to get too close to my lines, so I did another pass with the fret saw now that I've got clearance with all that bulk material out of the way. So I got real close to the lines with the fret saw, and then I finished the straight sections right down to the layout lines over on the belt sander, because that did a nice flat kind of sanding job. And then a little bit of filing to get into the corners and some of the trickier angles and so on, all just filing and sanding down to my layout lines. That's sufficient precision for this piece. The outer shape now is essentially done except for the back piece that fills in the U shape, and that whole end of it is still rough. So I can rough cut now a piece of material for the back, and I'm going to create 2 parallel edges and finish to dimension on one axis. But the rest of this back plate I'm going to hand fit to the U-shaped sheet metal because, of course, that's all hammer formed and hand filed and so on, so it's not going to be a perfectly machined, dimensionally flawless shape. I traced the outline of that onto the backer piece, and I filed my way down close to those lines and then did some test fitting and filing and test fitting and so on until I had what seemed like a perfect fit. I'm actually very, very pleased with the fit that I got there. The goal is to have 0 gap or as close to 0 gap as I can to make a really nice silver solder joint in there. That looks really good. To fixture that for soldering, I'm going to need to put some tiny screws in it, so I've got it clamped thusly in the vise, and I'm squaring up the piece to the sheet metal to make sure it's in the right place. And I've got layout lines on the top that tell me that the edge of it is in the correct location. And then I can very carefully center drill and tap some very tiny screws right down into the edge of that. I put 1 in each edge and then 1 in the bottom, so 3 screws all the way around to hold that in place for silver soldering. A little tricky, but that worked out just fine. Lots of practice doing that sort of thing from the boiler once again. Then those 2 parts get pickled, and I'll set these up for silver soldering. Once again, the usual rigmarole, flux on all the parts, the mating surfaces between them, and of course the fixturing screws also get fluxed to make sure we get solder inside the threads. Of course, nothing here has to be watertight or airtight or anything, so as long as the joint is strong, it doesn't super matter if we get perfect joints all the way around inside the screw threads and everything. It's not like the boiler where all of that stuff has to be absolutely molecularly perfect. Then some solder on there, and then heat from the far sides of the joints until that solder flows, and the scratch rod, make sure I get a nice fillet in there all the way around. This is a very easy part to silver solder, so no drama here. Then pickled once again, and now I can file the rough edges that are around that back plate down flush with the back plate to make a perfect end of a box, as it were. This is a technique I actually learned from Myford Boy. He recently made a fuel tank for a locomotive that he's building using the same technique. Go check out his channel if you want lots more excellent model engineering tips. Nothing fancy, just shows him working and little tips pop up on the screen. It's good stuff. Now there's the finished overall shape of the ash pan. It's looking pretty decent. Now I can put the hinge holes in there. And so for once again, I'm going to use my hammer form as a backer block. And the punch marks that I used to create the layout marks for the angles are still visible. Again, even though the die cam is long gone, the punch marks are still there, and I can get my edge finder pointer thingamajig in there, line up on that, and drill those out. That block of wood is just keeping the sheet metal from being lifted by the drill. It probably won't be because it's got plenty of strength around it, but just in case, it's cheap insurance. All right, that has gone very well. Now remember the grate rails, they have these very elaborate grooves milled into them. These are for the latching mechanism that holds the ash pan in place and allows us to hinge it downwards for cleaning. So it's time to make the pieces that fit into those recesses. They are made from stainless, and I started rough cutting out a piece to work with, and look at the bend in that. That offcut started bananaing quite dramatically away from the piece, which tells me that this material has a lot of internal stresses in it. So I'll finish rough cutting out my piece, but this tells me I need to normalize this before we machine it. There's a lot of stress in that, as is often the case with cold rolled material. And if it bananas that much just from bandsawing off a little bit of it, then it's really going to banana if we try to machine it. So normalizing just means heating it up to cherry red and then let it cool down naturally. And now you can see the banana that's in the factory edge there that should still be straight. So what we've done by normalizing it is released those stresses now rather than letting them come out as we're machining it. It doesn't prevent the banana, it just pre-bananas the part so that now we can machine it flat, straight, and square. If you don't pre-banana it, then it's going to banana right now while you're cutting it, and then essentially the part is probably scrap at that point. Internal stresses in cold rolled material are a real crapshoot. Sometimes there's lots and lots of them like this piece has, and honestly, most of the time, there's nothing appreciable. Like, I don't normalize every piece of cold rolled that I use by a long shot. Most of the time, it's fine. But sometimes you get a real bender like this one, especially stainless. I find stainless in particular has a lot of stresses. So the cold rolling process must be especially hard on stainless. Now I have a bespoke piece of material for the two latches. They're both the same overall dimensions, so I made both of them all at once, and now I'm going to cut this piece apart into the two rough blanks that I can make the little latch components out of. I'll zip through these a little bit because they're fairly straightforward. It's just a bunch of holes in different places. This hole here actually forms the inside of a U-shaped groove, which is the actual catch. So I drilled that out, and then I'll fret saw down into that hole, and then a little bit of filing will make that into a U-shaped groove. Next up are these flattened pins with a hole in them, and these hold the ends of the spring for the spring-loaded portion of the catch. I started by milling the flats over on the mill, and then I drilled the hole down through the center. Now, at this point, I'm actually going to deviate from the drawings a little bit because you can see how small this final component is going to be. And the drawings call for a tiny little shoulder on the back of this pin that slots into the other bracket that we were making. I don't know exactly why that shoulder is there, but it would be quite difficult to make at this size because either you have to do a second setup and turn it as a shoulder from the other side and try to hang on to like 10,000ths worth of material, or you have to cut it in the same setup using some sort of grooving operation, which then it's going to be difficult to hit your dimension, and all of that sounds quite difficult. Instead, what I did is I drilled the mounting hole out to full diameter, and I'm going to silver solder the entire thing in there like that. And what that means is all I have to do is part this thing off on the lathe right now, and we're done. My best guess for why that shoulder is specified is maybe because it makes silver soldering easier, but I would rather deal with the silver soldering challenge and make the part much easier. Now off camera, I made this little handle that has a curved end on it that I did with a file. This allows me to lay out and do the final bit of shaping on this bracket, which is the easement that allows the pin to slide up into the catch area. And once again, I did this with fret sawing and filing over on the die filer. Last bit of shaping on these brackets is to do a bunch of end rounding over on the belt sander. This is for appearance and also so that they'll fit into those round-ended recesses that we saw on the grate rails. Because of course those were made with an end mill, so there's a round end in them. Here are all of the little components that form the latching mechanism. It's a lot of little parts, a couple of which I made off screen because they're not exciting. Now these are mocked up with the pivot pins facing the wrong way just so they'll sit flat on the bench. I just wanted you to see all the little pieces in situ before we silver solder them because it's going to get harder to see what's going on in a second. Speaking of which then, over to the hearth to silver solder these assemblies. Everything got pickled, of course. Silver soldering things this small can be tricky, but I came up with a way to kind of balance them on some titanium strips and flux and heat and so on. If you keep the torch really far away from the parts, it helps not blow them away with the wind of the torch on these really small assemblies. A bunch of cleanup work later, and here are the two latching components. One of them is the actual swing latch, as you would expect. The other one, this little one, is actually a stationary piece, and it just holds the other end of the spring. And at the time, I didn't understand why that was a separate piece like that, but it will make sense in a minute. You can see that allows it to swing back and forth, the angle cut that we did there. And these pieces also are held captive on the inside of the frame rail, so everything has to still move freely while the frame rail is pressed up against it, like so. Off camera, I made a whole bunch of T-pins that hold all of these pieces together. Now I can empirically determine the correct position for the catch pin. So I'll mock up the assembly with the T-pins in the hinge there. Then with the assembly held parallel, I can mark the center of where the catch pin needs to go. The drawings recommend doing this procedurally rather than relying on everything having been built perfectly, including all the folded sheet metal parts and so on. That's a lot to ask of even the best model engineer, I think. So center punch that and then drill that out, and that's where the catch pin is going to go. Speaking of which, that was one of the T-pins I showed, and that gets silver soldered in there, which I did off camera. And finally, we need some civilized chamfers on the end of this because otherwise we'll catch our fingers on them all the time. They're kind of sticking out back in the operator area. There we go. Chamfers are what separate us from the animals, of course. And there are all of the pieces of this entire assembly. Lots of little bits. Let's get it all together on the locomotive. This was a little trickier than I expected. Because all of the pins and fasteners are all just held captive, there's no clips or threads or anything here. It's all just held inside the frame rails. I thought maybe the best thing to do was balance it all assembled and then kind of lift it up into place all as one assembly. And yeah, that just didn't work at all. I don't know why I thought that would work. Attempt number 2 was to fully install the port side rail by itself because it has no extra attachments. Then mock up the starboard side rail with the little catches kind of held in place and bring them up in and then tighten the screws in that rail. And that worked okay. Now the ash pan needed a little bit of precision fine tuning with my Starrett 864 Toolmaker's F-clamp in order for the catch pin to line up perfectly with the catch itself there. That's looking good there. But now to get the spring on there, and well, I'll save you 20 minutes of fiddling, which you can't see through my hands anyway. I learned that it's pretty much impossible to get the spring on this way. And now I understand why that latch is 2 pieces like that, why the stationary end of the spring is also a separate little bracket, because you need to attach the spring between them on the bench, then slide both pieces up in there together, and now you can screw it all together. And that catch works incredibly well. I am super pleased with that. I'm not even going to tell you how long I sat here doing this. It was extremely satisfying. Now we can slide the grate in there like so. If you're wondering, there's nothing actually that holds that grate in there. It just sits in there with the weight of the coal on it. And there you go. There is the finished ash pan. This all actually went quite well. Very pleased with that. It's working super well. Very, very satisfying. Thank you so much for watching. Thanks to my patrons for making all this happen. And until next time, I'll be here doing this.